section 10.2, hyperbolas. We have an equation here, 4x squared minus y squared minus 12x minus 4y equals negative 1. Because this minus sign here, it's probably will be in a hyperbola. The standard form for hyperbola, x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. And that's for a hyperbola opening left and right. For a hyperbola opening up and down, the signs will be reversed. Okay, so this is a hyperbola opening left and right with center hk, x radius a, and slopes plus or minus b over a. Okay, so first we want to put x with, we want to try to match our equation to that form. So the first step is to put x with x and y with y. And then we can factor the leading coefficients. So the leading coefficient of x squared is 4, and then inside parentheses we'll have, if we divide by 4, we'll have x squared minus 3x. And also factor out the leading coefficient of the y, and that's going to be negative 1. The 1 is understood. If we divide, we get y squared plus 4y. And then copy the equals negative 1. Okay, so now we can use the method of completing the square. We're going to take, and this is basically almost the same procedure we use for an ellipse, right? We take half the coefficient of x, half of 3 is 3 halves, and then square it. 3 halves times 3 halves is 9/4. Do the same for the y term. Half the coefficient of y, half of 4 is 2. 2 squared is 4. So we're going to add 4 to make this into a perfect square. And then we added numbers to the left side of the equal sign. In order to make this an equivalent equation, we also have to add the same numbers to the right side. The 9/4 that we're adding is inside parentheses with a 4 on the outside. So really we added 4 times 9/4. The 4 that we're adding is inside parentheses with a negative 1 on the outside. So really we're adding negative 1 times 4. Okay, so now we can factor each term on the left side of the equation. We're looking for x times x is x squared. We're looking for two numbers that multiply to 9/4 and add up to negative 3. And what works is negative 3 halves times negative 3 halves. For the y terms, we're looking at two numbers that multiply to 4 and add up to 4. And what works is 2 times 2. The right side of the equal sign, we just do the computations there, and that comes out to be 4. And then we can write this in exponent form. X minus 3 times x minus 3 can be written as the quantity x minus 3 quantity squared. The quantity y plus 2 times y plus 2 can be written as the quantity y plus 2 squared. And then copy the equals 4. So it's starting to match the standard form for a hyperbola now. The standard form, instead of equals 4, we have equals 1. In order to get equals 1, we can divide each term by 4. And then we can reduce. 4 divided by 4 is 1. So the new formula is x minus 3 halves quantity squared over 1 minus y plus 2 quantity squared over 4 equals 1. And now this almost matches the standard form. In fact, the book often it's close enough, the book often leaves it there. But if we want to exactly match the standard form, instead of a number on the bottom, we have a number. The standard form has a number squared. So we ask ourselves, what number to the second power is 1? And the answer is 1. So put a 1 to the second power there. For the y term, likewise, we have a number on the bottom. We want something squared on the bottom. What number squared is 4? And the answer is 2. 2 to the second power is 2. And also, the standard form has a minus sign there. Here we have a plus sign. So we can get a minus sign there if we put a double negative. Double negative is the same as the positive. So now it exactly matches the standard form, and we can identify the features of the graph. Okay. So h, number inside parentheses with x is 3/2. K, number inside parentheses with y is -2. A, the number on the bottom underneath the x is 1. B, the number underneath the y is 2. So the center, HK, 3/2 comma -2. 3/2 is the same as 1 and 1/2. So for the center, it's going to be 1 and 1/2 to the right, and then down 2. And then once we figure out the center, we can plot the vertices. The vertices will be 1 unit to the left and right of the center. And then the co-vertices would be 2 units up and down from the center. Co-vertices are actually not part of the hyperbola, but just if you see, the book sometimes discusses co-vertices, so if you see that, that's what they are. They're okay, so the slopes are going to be plus or minus b over a, which is b plus or minus 2 over 1. That means from the center, if we go run 1 to the right, we can either rise up 2 or down 2. A negative rise would be down. And then that's enough information to plot the graph. So we have the center, 1 and 1/2 to the right, down 2. I put that in black because that's actually not part of the hyperbola, it's just a feature of the hyperbola. And then if you go 1 to the right and 1 to the left from the center, you'll have the vertices of the hyperbola. They're actually a feature of the hyperbola. I put those in red. If you go up 2 and down 2 from the center, you have the co-vertices. There's also special points called the foci. We have 2 of them, and there's a formula for computing that. You don't really need to know the foci to draw the graph, but that's a feature of the graph. And then there's the asymptotes. So the asymptotes, the slope was plus or minus 2 over 1. So if you go over 1 and up 2, you're going to have a point on one of the asymptotes, and you can connect the dots. I put it with a dotted line. And if you go from the center, go 1 to the right and down 2, you'll have a point on the other asymptote, connect the dots. And then to draw the actual hyperbola, from the vertices you want to draw a curve going toward the asymptote. So start from the vertex and go toward the asymptotes, and do that on each side. So this kind of reddish brownish curved line is the actual hyperbola. So some of the applications require knowing the focus of the hyperbola, and so you want to compute c, which is square root of a squared plus b squared, putting in the numbers square root of 1 squared plus 2 squared, square root of 1 plus 4, which is square root of 5. 5 is not a perfect square, it's close to square root of 4. Square root of 4 we know is 2, so square root of 5 will be a little more than 2. Through trial and error, we could estimate it to be about 2.2. And then the foci will be 2.2 from the center going past the vertex. There's some additional terminology. The line segment connecting the vertices is called the transverse axis. Line segment connecting the 2 co-vertices is called the conjugate axis. And that concludes this presentation.